Hey kids, welcome back. This is Module 3 and it's Lesson 13. And our objective today is a little off of what we've been doing. So every now and then they'll throw in these kind of algebraic, learn to think like a mathematician type activities. So it is an important skill. In fact, sometimes I look at these and think this is more important than actually doing the math, because in life we do a lot more kind of estimating. What am I close to? What is the reality of this number? So if we're going to use fraction benchmark numbers to assess reasonableness of addition and subtraction equations, it's kind of just understanding the size of fractions. Very important skill. So a tool that you can think about during this activity is a number line. You're not going to have to draw a number line, and I know everybody just went, hooray! But you're not going to have to use one, but it's really good to understand what these fractions are, where they fall on the number line, where is 0, where is 1/2, where is 1, where is something that's more than 1, or an improper fraction. You might have something, we're going to be doing some comparing, so it's going to be greater than 1 is an option. And so what is a benchmark? If I keep saying benchmark, benchmark, what is that? Well, a benchmark is a predetermined point. Okay, so it's something that you can compare to. So if 1 is the benchmark, then we're going to compare, is it less, is it more? So let's take a look at a couple of little sample problems like this simple addition, 1/4 plus 1/2. And the question might say, is it greater than 1? Is it less than 1? Is this a true statement? Is it false? So what is it that we're trying to determine? And so if they give you this, they would say, is 2/6 a reasonable answer? And, some kids will look at this and go, 1 plus 1 is 2 and 4 plus 2 is 6. And I'd say, no, oh my gosh, don't ever add denominators that aren't the same. No, 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 no. But another reason that you can determine that this isn't reasonable is also because half of something, okay, well, that's half. But if you have to add to half, then you should be getting closer to 1. But the answer you got here, 2/6, is less than half. And so that's not even a reasonable answer to get if you were adding these things up. So some kids will just, I'm desperate for the answer, and they just start putting things here and there. But you have to really think in math, is this reasonable? Did I get something that's even close? Another good, helpful tool is to think about money and quarters, breaking up $1 into 4 pieces, 2 pieces being 50 cents, 1/4 of them being 25. Great tool to use to help you think about reasonableness. Also, in subtraction, when looking at a fraction like this, 2 out of 3 parts is almost the whole thing. Taking away 2 out of 9 parts, is this a reasonable answer? And then we'll be talking a little bit about common denominators, but not a whole lot. They're going to give you some pretty easy stuff in this lesson. Let's jump right in, and I'll show you what we're talking about so we can start comparing. Okay? Alrighty. So, Lesson 13. Are the following expressions greater than or less than 1? Circle the correct answer. So it's really easy, I'm telling you. Maybe I'll zoom it in just a bit. Are the following expressions, okay, so 1/2 plus 2/7. So if you think about where we are with 0, half, or 1. Half is half, easy peasy. What is this one in terms of half? Well, what is half of 7? Well, half of 6 is 3, and half of 8 is 4. So we have to go in between 3 and 4, which is the 3.5. 2 is less than that, so we're less than half. So if I have a half and a half, I'd have 1, but I have less than half. So if I have half and less than half, then I'm going to have less than 1. And that's how you reason with these, okay? Let's take this one. If I have 5/8, which is 4 is half of 8. Again, look at the denominator, find the halfway. If 4 is half of 8 and 5 is a little bit more, and 3 is a little bit more than half of 5, then I have greater than half and greater than half. So both graders would give me something greater than 1 as my total. Okay? Now let's take a subtraction problem. So if I have 1 and 1/4, that is like that quarter, like, if you're using money. Okay? So it's like $1.25. But 1/3, remember, is a bigger piece than fourths. Remember that if you have ones on the top, then you compare the size of the denominator, and the smaller the number, the bigger the piece. The bigger the number, the smaller the piece. So if I have 1 and a little extra, but I take away all the extra and more, I'm actually going to end up with a less than 1. Okay? Because I'd be, taking away more here than that. I know it's so weird. Kids will look at this and go, I don't get it. 1/3, 1/4, I don't get it. But think about, make a donut or something and actually cut it into pieces, or a cookie or a granola bar, and you'll see what I'm talking about. Next one, 3 5/8 minus 2 5/9. So where are we when we look at the whole number subtraction? Well, 3 minus 2 is 1. And then I have 5/8, which is a little bit more than half. And then I'm going to take away 5 out of 9 pieces, which is, when you compare these, okay, the denominators, the ninths are smaller, and I have the same number. So we would end up with a little bit. This is a very, very tiny difference, because you're going to take away less than what you had. You're taking away less than what you had, okay? So we end up with something greater than 1. Now, moving on to number 2. Are the following expressions greater than or less than 1/2? Circle the correct answer. So now we're really narrowing it down, okay? Just looking at these. What if I have 1/4 plus 2/3? Okay, so I have actually the quarter here, and then 2 out of 3, it's like if you break 100 into 3 parts, you'd have 33 and 33, so that'd be 66 roughly, okay? And so are you going to end up with greater than half or less than half? Well, this here alone is greater than half. So you're going to have greater than half as your final answer, because 1.5 out of 3 would be half, and we have more than that, and we have more. How about 3/7 minus 1/8? Okay, 3/7 is pretty close to half, but it's just a little bit less. Okay, and then I'm going to take away from that. So it's a little bit less to start, and then I'm going to take away. So we end up with less than half. How about this one? 1 1/7. So I have a little tiny bit more than 1. Okay, and then I'm going to take away almost 1 whole. So if I have, and again, if you want to use a number line, you can kind of look at it this way. If I have 0 and I have 1, and then I have a little bit more than 1, but I have to take away almost a full 1, then where are you in relation to half? You're going to be less than half, because you're taking away almost the full. It's 3/7 plus 2/6. Another one, okay? What if I have the 3/7, which is just a little bit less than half, and then I have 2/6, which is about 1/3, 1 out of 3. You can hardly help yourself making equivalent fractions when you look at these, okay? And so you're going to end up with, if I have a 1/3 here and I have almost a half here, you're going to be greater than a half, because you put those two little pieces together, but you're just under a half, and then a little bit under a half, but less. And so when you put those together, you're going to be at greater than half. So use a number line to help you. If you want to just put one off here on the side, it can be very helpful. How about let's make comparisons. Now, comparisons are greater than, less than, or equal to make the following statements true. Now, we have to make it true. So remember, an equation is a balancing act. So when you balance it, if it's equal, then it's exactly the same. But if you have a balance and one side is heavier than the other, then you have to show the greater than or less than sign. So let's take a look at what our options are here. If I have 5 and 3, well, I know that's going to add up to 8, okay? So you don't have to do a lot of solutions. This is more about thinking. But look at what we're left with. When I have 8 and then I'm comparing and I see I have 8 here, I also have 2/3 and I have 2/3 here. This side then I have even more. So I know this side is going to give me more. And when you remember to make your symbols, your greater than, less than symbols properly, 2 dots for the greater side, 1 dot for the other, and then connect the dots. Or if you want to think about the big mouth, are going to eat the greater side, sometimes students will think about it that way too. Let's move on to this one. So if I have 4 and 5/8 minus 3 and 2/5, and again, it's a balancing act. So what am I doing? I'm taking 3 away, so that's going to leave me with a 1. And then I have a little bit more than half, and I'm going to take away a little bit, just under half. I have a little bit more than half, and I'm taking away a little bit less than half, so I'm going to have only a very tiny amount, okay? And again, you don't have to solve them. This is just about reasoning, okay? So I have 1 and a tiny bit here. Here, I have 1 and 5/8, which is already more than half of the next one. I have 1, and I have a pretty big chunk. And then I add more. So the right side is going to be more in value because we're taking what we have that's the same, which is the 1, and then we're comparing what's left. This has a tiny amount, and then this is going to have not only the 5/8 that we have on this side, but we're going to add to it. So this side is greater. Okay, next one. 5.5 plus 1 and 3/7. So if I'm thinking about values here, and I look at that whole number, and then you can also see that sometimes when you look at those denominators, okay, if you kind of can't help yourself, like you see, ooh, I'm getting really close, and you have 14ths and 14ths, and just leave that alone. If I have 7/14 and then 6/14 here for these, and how did I get them? Because I'm using the other number as the scale factor. Okay, so 7 here and then 6 here. I can see that I'm going to have the 6 and 13/14 on both sides. So you can put the equal sign for this one. Okay, so sometimes when you see that, yep, it's going to have that same denominator, you can go ahead and do a simple calculation. And the last one, 15 and 4/7 minus 11 and 2/5. And compare that when you get your 4, right there with the whole numbers, to 4 and 4/7 plus 2/5. So again, looking at this sign, subtraction versus addition, here I would have to take this away from here. So in addition, I shouldn't say in addition because we're not adding. After solving for this subtraction, you then need to subtract more. Okay, so this has another step of subtraction. This one has more addition. So this side is going to be heavier after I do my calculations with common denominators. All right, so I hope that was helpful. Oh, and then, guess what? I ran out of white paper. I am not running to the office right now because the weather is very unhappy. Don't want to run a quarter mile and go get a ream of paper. No thanks. It's cold out there. So let's do this one. Is it true that, and again, here's the is it true. This is kind of more like what we were just doing. That 4 and 3/5 minus 3 and 2/3, so this is the whole side of this equation, is equal to 1 plus 3/5 plus 2/3. So everything on this. And it says prove your answer. So if I was to take this as like a regular problem that I'm setting up, and I take my 4 3/5 minus 3 2/3, and I start solving that, I get 1. And then I have 3/5, but I have to still take away the 2/3. Now, this is looking a whole lot like this side, okay? But there's a slight difference. I have 1 plus 3/5, but this side has plus 2/3, and this side has minus 2/3. So is it true? No, it's not true. Okay, so one side has minus 2/3 instead of plus 2/3. And so you can't have different operations and have it be equal. It's just not going to work out for you. Okay, it has to be equal in value on both sides. That's what equals means. Okay, let's do another one. Jackson needs to be 1 3/4 inches taller in order to ride the roller coaster. Doesn't everybody know what that's like? Since he can't wait, he puts on a pair of boots that add 1 1/6 inches to his height and slips an insole inside to add another 1/8 inch to his height. Will this make Jackson appear tall enough to ride the roller coaster? How much taller does he need to be? 1 3/4 inches taller. So he must be the 1 3/4 inches. So what I need to do is I need to look at the things that he's doing to make himself taller. 1 1/6 and the 1/8. And then we're going to compare and see if this is going to get us the 1 3/4. Now, oh, there go the lights, but not all the lights, only some of them. All right, so I don't have to actually solve and get the full answer. So this is, again, they're just saying, will it make him tall enough? So it doesn't say how much taller or what's the difference. So when I look at what he needs, okay, so he needs this, which is 1 and almost another whole, and he has 1 and a tiny bit, and another tiny bit. These are tiny. 1 out of 6 parts is really not very much, and 1 out of 8 parts is even less than that. And so when you look at these two amounts and you compare them to 1 3/4, and this is 1 and almost all the parts, okay, this is not very much, and it's definitely not as much as the 3/4 put together. Okay, and so no, unfortunately, he will not be tall enough. Sadly, poor Jackson. Next time. Okay, last one. A baker needs 5 pounds of butter for a recipe. Holy moly. That is like artery clogging butter. She found 2 portions that each weigh 1 1/6 pound and a portion that weighs 2 2/7. So notice that if you were to make a tape diagram, it's 2 portions of 1 1/6. Don't forget that this is kind of a doubled. 2 portions of that. So you have to have this one twice. And another portion that weighs 2 2/7. Does she have enough butter for a recipe? Well, let's take a look at just the whole numbers. 2, 3, 4. Then I would still have to put together my 1/6, my 1/6, and my 2/7. And she needs a total of 5 pounds. So when I look at this and I think, I have 4, but do these make 1 whole? That's the question, because I need to get up to 5. Do you think it's going to make 1 whole? 1 out of 6 parts, and 1 out of 6 parts would make 2/6, which is only 1/3. 1/3 is less than half. 2/7 is also less than half. So if I have less than half plus less than half, bummer for the baker. No, She does not have enough. Sadly, but you know what? We could have a whole other problem and say, hey, baker, make half the recipe, and then you will have enough. And then you should share with us. No, she does not have enough butter. Click subscribe, come back again. We will have more math fun on future videos. I hope this is helpful, and we'll see you on the next one. Bye for now.